Hello everybody, it's Mr. Arocena, and on today's video we're going to be going over this circuit problem from the Circuits Worksheet. Unlike the previous one I did, this one only gives you information about the resistances and the total voltage. We're going to be using Ohm's law to help us find the current, and we're going to be using the power equation to help us calculate the power. And on top of this, we'll also be using Kirchhoff's laws, so both the current rule and the voltage rule. Alright, now the first step for a problem like this, since I don't know anything about the current, is to figure out what the total current is. Now, in order to figure out total current, we're going to need to figure out total resistance. And to figure out total resistance, it looks like it's kind of hard, but it's actually not really, because we simply just have to break it down by picking two pairs of resistors and then just combining them. And then just keep doing that until we get down to a single combined resistor, and that'll allow us to figure out the total current. So for example, here, I will take these two, I will combine those into a single 6 ohm resistor, because they're in series with each other. Then I will take this 6 ohm resistor and combine with that 6 ohm resistor to be in parallel. So that total resistance, it's going to be really convoluted. So I'm going to call that resistor 156, because that's the 1, 5, and 6 resistor combined together. Now that combination is actually in parallel, so I should write it like this. And this will be 1 over the 6 ohm resistor plus the 1 over the combined 1, 5 resistor, which is also 6 ohms. This will end up being 1 over, we'll call it R156 equals 2 over 6. So that combined resistor is basically 3 ohms. Now we can take that combined resistor. So this combined resistor here is really just 3 ohms. That will be in series with this one. So that would be 6 ohms altogether. So we'll call that resistor, I guess, 3 combined with 1, 5, and 6. That will be altogether 6 ohms, because we have the 3 ohm combination. So this combination of 3 resistors is really 3 ohms, and that's in series with that one, so that is altogether 6 ohms. Okay. So that's the top part done. Now we kind of repeat the process for the next pair of resistors. So here, this pair of resistors is in parallel, so we'll call that resistor 412. So in parallel, resistor 412 will be 1 over 4 plus 1 over 12, which ends up being 1 over resistor 412. 1 over 4 plus 1 over 12 is going to be, I believe, 4 over 12? No, 4 over 12. Yeah, 4 over 12. So that resistor combination ends up being 3 ohms. And then that pair of resistors is in series with that resistor. So we'll call that resistor 4129, I guess. Lack of a better name. 4129 is going to be the 3 ohms plus the 9 ohms for a total of 12 ohms. There we go. Alright, so now we've broken this down into a single 12 ohm resistor. And this 12 ohm resistor is in parallel with that 6 ohm resistor. So we'll just call it R combined. R combined is in parallel. So the 1 over 12 ohm resistor is in parallel, or 12 ohm resistor is in parallel with the 6 ohm resistor. So this will give me my R combined is going to be 3 over 12, which ends up being 4. My R combined is 4 ohms. Now the R total is you take that massive combined, let's highlight it. So this massive combined resistor, or combination of resistors, is really just 4 ohms. And that 4 ohms is in series with that 2 ohms. So my total resistance is going to be 2 ohms plus 4 ohms, which is now 6 ohms. There we go. So now I've got my total resistance. Total resistance is now 6 ohms. Using Ohm's law, we can then calculate current as V divided by R, so that gives me a current of 3 amps. And then the power is just I squared times R, so that's 3 squared times 6, so that'll be 54 watts. So total power, 54 watts. Alright, now how do I go about calculating the voltage and the current at every other spot in the circuit? Well, let's start with a 2 ohm resistor. 2 ohm resistor, because it is on the same path as that, then that'll have the same amount of current flowing through it, so 3 amps. We can calculate the power as 3 amps squared times 2, so this will be 18 watts. And the voltage will be I times R, so 3 times 2, so this will be 6 volts. There we go. Now, how do we go about doing the other ones? Well, let's just get a clean diagram again. Alright, so putting in some values, this was 6, this was 3, and this was 54. This is 3, this is 6, and this is 18. Okay, so now we've got some values and we've cleared up a little bit more. Alright. So going back to what we calculated earlier, this combination of resistors is 6 ohms from our previous calculation. This combination of resistors is 12 ohms. Now we know that because of Kirchhoff's voltage rule, we know that the voltage going through this path plus the voltage going through here has to equal this 18 volts altogether. So that means then that there is 12 volts going through this particular combination of resistors. So if this was if we combined all of these resistors into the single 6 ohm resistor we calculated, there would have to be 12 volts of 12 volts of electricity going through this single 6 ohm resistor, based on Kirchhoff's voltage rule, because 6 volts is at this resistor, which means 12 volts must be at this resistor. What that'll allow us to do is we can then calculate the current that is flowing through this path if it was a single resistor, and that would then just be 12 divided by 6, so there would be a total current of 2 amps flowing through that. Now what that means then is that the 2 amps must be in this portion of the circuit here, which flows through this portion of the circuit here, and then gets split here. Okay, so the 3 ohm resistor will have a 2 amp current flowing through it, which means we can then calculate the voltage, so 2 times 3 is 6. Power is then 2 squared, so yeah, power is current squared times R, so 2 squared times 3 this will be 12. Right. Now how do I go about calculating the current in this portion of the circuit? Well, here we can actually reason it out a little bit, because I know that, okay, if my going to Kirchhoff's voltage rule, if my electron were to travel down this path, it would mean that this 6 ohm resistor would have to get some voltage so that Kirchhoff's voltage rule takes effect. So we know that 6 volts passes through this one, we know 6 volts passes through this one, and because it has to equal 18, we know then that 6 volts must pass through this resistor here. So we can write that down. And that's one path basically. You have a 6 volts, 6 volts, 6 volts. And that equals 18 because once the electrons go back to here, they basically fly back to the battery. Right. So now that we know that how much voltage is going through here, we can calculate the current. Well, 6 volts over 6 ohms is going to give me a current of 1 amp, and this will give me a power of 6 watts. Now, if I know 1 amp is flowing through here, and I know that 2 amps flows into this junction, this means that 1 amp must flow through this path. So now I can write down 1 amp here, 1 amp there, which will allow me to calculate the voltage as V equals IR. So 1 volt, this will be 5 volts. And then calculate power, I squared R. So this is 1 watt, and this will end up being 5 watts. Yeah, there we go. Alright. So that completes that segment. And to sort of check, we can use Kirchhoff's voltage rule to check. So if I go through the 2 ohm resistor, the 3 ohm resistor, the 1 ohm and back, that should give me 18. And you can see that 6 plus 6 plus 1 plus 5 equals 18. So the check works. Right, then we'll apply a similar set of thinking to figure out the next set. So I know that going into this junction, I have 3 amps of current flowing through it, which means that if 2 amps flows in one way, that means 1 amp must flow this way. And 1 amp is going to get split up here and split up here, and then it's going to rejoin here, so flowing through this portion of the circuit, we have 1 amp, which we can put into here, 1 amp. And then we calculate the voltage as V equals IR, so this will be 9 volts flowing through there. And then power, I squared R, this would be 9 watts. Alright, now to figure out the current or the voltage in one of these resistors, we'll just pick one. And we just trace the path. So if I'm going through the 2 ohm resistor, through the 4 ohm resistor, through the 9 ohm resistor, all those voltages must add up to 18. So I know that 2 ohm is 6, the 9 ohm is 9, that's 15, which means then that the 4 ohm resistor must get 3 volts. So to maintain the Kirchhoff circuit rule, or Kirchhoff voltage rule, sorry. Now, you can apply a similar logic then, that if I go through the 2 ohm, 12 ohm, 9 ohm, this will also be 3 volts to maintain the Kirchhoff's voltage rule. And then we can just calculate current as 3 divided by 4, so this will be 0.75. 3 divided by 12, this would be 0.25. Then we calculate the power, this one I cannot do. Alright, so putting this into our calculator, 0.75 squared times 4, this would be 2.25, and then 0.25 squared times 12, this would be 0.75. And there we go. And that's how we would solve this circuit, and all the parts of it. Now, one really neat thing about this is that because of conservation of energy, if you were to add up all the powers together, it should equal the 54. And that's kind of one final check, is that all of these should equal the total power of the circuit. It's kind of neat. Anyways, there you go. So if you get any complicated circuits you need to analyze, depending on the information you have, just use Kirchhoff's rule, Ohm's law, or Kirchhoff's rules, Ohm's law, and the electric circuit power equation, and just apply them. If you guys have any questions, you know how to contact me.